Okay, so the last one is how to analyze problem involving wall surface impact. Okay, so as I mentioned in my previous video, we only have one figure. Okay, before and after only in one figure. You have this one, this is wall, so this is before, this is after, only in one figure. Okay, now you have to construct anti-axis. Okay, anti-axis, which is n-axis 90 degree to the surface. So this is the surface, so this is your n-axis 90 degree. So the t-axis tangent to the surface or 90 degree to n. So this is the t. So you have the anti-axis. Now you want to resolve and label all known velocity. Okay, so the velocity that you know, you have to resolve it and label, meaning that you have to label it is velocity in n-axis and velocity in t-axis. Okay, now after that you can solve for t-axis, same as previous one. We can solve using, we put velocity before is same to velocity after impact in t-axis. Here we only have one, VA and VA, because the other component B, so you can consider this is B, the wall is not moving, so the velocity is 0, so this is the only component that moving, which is A. Okay, so now after that one, we assume the direction for the velocity that we didn't know in n-axis. Okay, so and then you can solve using this equation. Okay, you can solve, remember that we have two equations, coefficient of restitution and conservation of momentum. In this case, we can only use the coefficient of restitution, equation for coefficient of restitution, because the conservation of momentum we can apply in this case, because the wall, the other part is not moving, the velocity is other part is always 0 before and after impact. Okay, so in this case the momentum is not conserved, so we cannot use this equation. Okay, that's all. Okay, now we want to do this exercise. Exercise 7.18, page 147, for wall surface impact. Okay, it is said here that a 0.5 kg steel ball B strike on inclined plane theta to the horizontal. Velocity before and after impact are as shown. Okay, the coefficient of restitution E is 0.6 given. Determine the angle theta and the velocity of B after impact, which is VB, VB2. Okay, so let's say here we have exercise 7.18, page 147. Okay, E is given as 0.6 and B is 0.5 kilo. Okay, determine the theta and the velocity. Okay, so we need to find what is theta and VB2 is equal to. Okay, so what we need to do is now to construct before and after diagram, which is in this case only one diagram. Okay, one diagram, and we have here. Okay, so this is before, this is after. Okay, so they call it, this one, the wall is A and the other part is ball B. Okay, now we have construct before and after diagram. Now we want to construct anti-axis. Here it is already given to you the anti-axis. Even though if the question didn't give you this anti-axis, we still can construct the anti-axis, which is the first one, the n-axis is 90 degree to the surface, towards the surface. So this is the n-axis, and t will be 90 degree to the n-axis. So 90 degree to to the n-axis and towards the direction of motion, which is movement like this one. So we have this is the t-axis. Okay, so now we have the anti-axis. The third one is to resolve and label the component. So here we have the theta. Okay, we have the theta. Okay, so given, now the one that is given to us is this one is at the beginning we have this direction is VB1 equal to 10 meter per second, and the other one is we have this one VB2, which is we didn't